let's start. If everyone is okay, we can start our lecture, and the other participant can join us during the lecture. Hello, everyone. My name is Mohammed Hassan Saletaveri. Um, I am the head of the research and development department in Havan Architecture Company. In today program, we have three parts. In the first part, Mr. Kermani will come and talking about the general uh, aspect of the intelligence architectural design to you, and talking about the basic facts. After that, we're going a little deeper inside the subject, and in the next part, in the last part, we are going to talking about the mathematical calculations and the graph theory, and we're going to practice it a little example together. So in the first part, I invite Mr. Kemani to come and start his lecture, um, and we are going to the next program.
Hello, everybody in this room. I am Human Kermani. I am CEO of Havbana Architecture Consultant, which has founded 15 years ago in Tehran, in Iran. We conducted a variety of projects in different scales, from high-rise building, healthcare centers like hospital, railway station, to interior design projects. In this workshop, two of my colleagues will accompany me and we will give the presentation to you. Mohammad Saletaveri and Mrs. Fereshte Khojastemer, both of them are graduated from an Iranian architecture university in technology of architecture with MS degree. As we know, artificial intelligence, AI, is a word that you can hear in different fields and contexts today, and becomes a trend topic in all different scientific fields and also in industrial companies. And it is a topic that finds in its way in a very different fields, from car manufacturing, industries, entertainment, multimedia, film and animation making, and also in architectural process. This topic, AI, is not really a new subject for us in our profession. For example, Mr. Nima Zandinia has finished his thesis in Delft University in 1992 by the subject, the AI in the future of architecture. Or Big Oxman Rebecca has a famous sentence. She said, in the following years, design research has developed the relationship between design, cognition, and computation, which have become an important topic in design studies. She said in 1992, about 3 decades ago, so it's not a new topic for us. Although there are lots of efforts in computational design, generation design, and artificial intelligence in computational process, the achievements and outputs of them did not become prevalent in our professional world till now. And we can see them popular in use as a tool for architects. Nowadays, with the development of relationship between technology and architecture, we can see that there are too many companies trying to develop new platforms and frameworks that contribute between information technology and architecture. For example, one of the best intelligence platform and plugin application that is available for urban planners and architects is Depth Maps X, developed in UCL University and is really helpful for visual analyzing. Our company, Hafbano, is also trying to take steps in this way in this R&D department. Our goal is to achieve an intelligent design process that aid architects in complex problem solving and design. So the development of AI platform becomes a mission for our R&D department in Hafbana, which Muhammad is its head. We entered the AI in our projects, not AI only, intelligence tools in our designing. It started by intelligent tools, and now we are entering the AI in designing. I will show you some example of that. Generative design process also guides us to human and machine interaction, which is one of our main outputs of AI. Actually, as we know, architectural process has three phases: analyzing, generation, and evaluation. Machine doesn't have the key feature of designer, which is called creativity. Indeed, creativity is the main difference between us and machine. For example, we as an architect have an interdisciplinary position for linking those three phases, which I told you: analyzing, generation, and evaluation. And our creativity help us in this situation, that how to link these three phases together. I believe that AI as an intelligent tool just help us to enhance our knowledge and boost the design process. It gives us enough time to create instead of doing the iterative process for many times. I mean, machine doesn't have cognition and conscious enough to do things by itself. Machine just do the analyzing process for the architects or other users. Outputs that we receive from the machine can vast our solution space, and we can select our desired option. Now we want to present our first product, which we call it Termite Nest. Indeed, beta version of Termite. Termite is one of our main production in our R&D department, and most of our products have based on the methodology which Termite has been created. Termite Nest is a tool that aids designers and architects to reach a good collaboration with machine. And Termite Nest could be named as sort of generative tools with so many fascinating company and utilities. I'm going to show you some examples, some of work, and my colleague will show you some of that. Sorry.
Hello everyone, thanks for Mr. Kermani. I am going to show, and for his introduction, I'm going to show you two of our projects that led by Termite Nest on generative design in our R&D department, and a little explaining the efficiency of the Termite Nest in the design process. And the first one is about the interactive environment that is built for us. And we use, and in this environment, we generating an algorithm that evaluating different geometries based on the energy efficiency, and the main importance generating the spatial plan, a spatial configuration inside the geometry. So as the algorithm design different geometry shape for us and evaluating the energy consumption for it, Termite start to generating the spatial plan inside the geometry and aid the energy plus to calculating the energy efficiency inside the geometry. So we have a much more accurate energy consumption for each geometry, and then we classifying the result in three type of architects, the area and the mass that they have. And as you can see, this is a three-dimensional solution space that provided in this framework. So we could select the geometry shape which is desired with our architectural preference, and then we're going to develop it. Here is the example of the from the solution space. We can add the architectural elements on it and put the morphological and starting the morphological phase upon this on these shapes and creating different forms based on them. And this is a little explanation about how we can use this generative design. And also in the healthcare building, we also have another example of using termite nest. Uh, as you can see, we are going to do this at the end of this workshop together. We are going to generating a plan together with the evolutionary process, and this is an example of how termite can do this for us. In this example, we use the topology and relations of the spaces, and we put this in the evolutionary process that termite leads for us, and it generates different forms and layout. And after that, in the final step, you can see we reach different shapes which are raw, and then we are trying to modify it and create the final form and layout which is satisfy our desires as an architect. So thanks for your listening by now. I hope you enjoy by the lecture by now. So now we are going to uh, start our main topic about the design process and how this design process could be combined in different systematic way and how can we interact with it. So my colleague, Mrs. Ferishte, will continue the lecture and show us how the design process could be subdivided into different phases and how these phases are worked together, and clarifying the main methodology for us.
Hello everyone and welcome to the webinar. I'm a computational design researcher. My name is Fersha Khojasnamer and I'm going to continue with the lecture. We are going to speak about parametric design thinking in space planning. And first of all, we are going to start with design process. In architectural design projects, architects need to split the process into subparts and work on each step gradually to complete the whole design. So if we consider design process as being just one step, it cannot be possible, and it increases the complexity of design process. So it should be done in steps and coming after each other. So incrementally, it can be performed to take an output of design. We can see the flowchart of design process in this slide. As you see, there are design requirements that should be entered to the process by the user or by architectural design standards. And the first step of design process is analysis or formulation, where we start to interpret or translate the design requirements into numerical data and quantitative or qualitative data that can be used for the next step, which is generation. Generation or synthesis, when we start to create values, create qualitative information based on analysis step, and to create architectural design. The next step, which is the last part, is evaluation, which in this part we use standards from architectural design or from the users to evaluate our design process, our design outputs, and this can be done in a recursive loop. We can do it repeatedly to check our design requirements and maybe manipulate them. And so we test and tune our design solutions to get our desired final output. We spoke about the design requirements, and I want to a little make them clearer. The requirements of every design project is especially and specific in its context and how it would behave or act. And generally in architectural design, we have some design requirements, especially if we want to speak about plan design. We need to have a physical program which consists of the design spaces, their relationships or their connectivity pattern, their area and size and shape, and other factors that may contribute to the design output. One of the main interests in the last decades is the automating the design process. And this will help architects to make them free from the analytical and numerical phases, which were in the first step, and make them to have more, to make them free and let them to enhance their creativity and focus more on the generation step rather than the analysis step, which was the first part. In the last decades, most of the use of computers in design process were CAD oriented, computer-aided design, where they usually use computers for representation of their design outputs. And the computers can absolutely be beneficial for drawing phases and to facilitate the design representation. However, this use of machines or computers can go further than this step and also be involved in analytical and also qualitative processes, and also they can help in design decision making. And because of the combinatorial nature of design, this automating the design process is a complex and a difficult task. And there have been lots of efforts in this task. However, most of them do not have the quality required for architects to use these methods. So in this stage, we still have to work more on these qualities and use the benefit of human-computer interaction in a better way. Okay, and what we need for our design automation is to know that design is a complex and combinatorial problem, and also it is a cognitive process. So we need expert knowledge to use for starting our design problem, and to translate or transfer it to machine language, we need to interpret the data or the user inputs or design requirements and constraints to numerical values. So numerical calculation is the most way that machine can understand what we order or what we need for the design output. So it's very important to program the design knowledge and the design requirements that are ordered by the designer. And so this is the summary of what I told about the automating process of design or architectural design at all. And that we need expert knowledge of design, we need a deep reasoning strategy in order to program the architectural design rules, and also the deep reasoning about mathematical analysis, which would be very helpful in machine language. And as I told in the slide about the flowchart of design process, we need to do the design process in a recursive loop and test and tune the design outputs and repeat the process in order to get to the desired output. And now let's get deeper to space planning, which is our main focus. The definition of space planning is generating or creating some layouts or plans by arranging or placing different spaces, or we can also tell it in common, two or two-dimensional components based on some basic rules. And these rules are functional, topological, and geometrical constraints that make a plan to work based on the design requirements. And again, I can continue and I can refer to the flowchart that we told there are two main steps. The analytical or programmatic step, which we use the design requirements and interpret those data to machine language. And the next step or synthetic phase, which can be a combination of generation and evaluation, is about creating the result and also evaluating it based on the architectural standards. Now the first step, which was the analytical phase, as I told, the design requirements are surveyed and studied in this phase, and they're interpreted to machine language. One of the important issues or topics in this phase is the matrix of required adjacency or adjacency graph. And what this matrix is about is that it will show us the interactions or the connectivity pattern between spaces, which is very important for us in the process of plan generation. And it consists of numeric values, which shows the existence or non-existence of the relationship or connectivity pattern between spaces. It can be interpreted in two ways. It can have 0 or 1 values, which shows the existence or non-existence of this relationship, or also they can use real numbers or a threshold value with, for example, less numbers or shorter numbers for showing the less connectivity between two spaces, and using larger numbers for showing the stronger connectivity between spaces. So we interpret our design requirements like graphs and making them more clear by these diagrams and schematic base. And the next step would be interpreting those shapes to real architectural plans. And as I mentioned before, we need functional and also topological standards and the inputs to create these schemes. And in this slide, we again can understand that there are 3 levels for this making the plan generation. The first steps, we need to have the locations or the spaces, their names, their area, their shape, which is the metrics, and also the topological arrangement. And we can say that a floor plan can be similar to a cluster of data. And this set of data has some basic relationships between them and the connectivity between maybe the rows and columns. So again, in this design and the diagram and the spaces, they have this kind of connectivity patterns. And now my colleague, Mr. CAADRIA, will continue with more in-depth information about space syntax and graph theory and how they can contribute to plan generation.
Okay, thanks for your explanation. So we're going to continue our lecture and diving into the methodology much more deeper. Let me just sharing my screen. So we came here now. So uh, the topic that we're going to talk about is a space syntax in this phase and step. We talked about the space relation, and we showed this bubble diagram and the graph that architects are drawing for themselves when they're in the early design process step. And we are all are familiar with the design thinking more or less, and how architects think in their design phases. So architects experimentally doing this when they're trying to sketching the layout of their plan. So they're going to represent their spaces as bubbles and trying to linking them with lines, and that represents that these spaces are related to each other. And as their circles getting far from each other, it represents that they are has lesser relationship together. So if we want to organizing these relations, if we want to organize it in the calculative way and introduce it to the machine, so we need to use an algorithm. And so the algorithm which is really beneficial in this step is a space syntax, which is a configuration, which is a configurational analysis, which is developed by the Bill Hiller and his colleagues in UCL University. It has a very well-known name. So we are going to talk about how it works and why we need it and how we can use it in design automation. So as it's described here, a study of the relation of the building's part is what space index do for us. And the outcome of this can aid us in so many different phases. For example, when we want to analyzing the different pattern of the plans. For example, in a same usage, for example, I'm talking about a house plans, we have different kind of plans that came from the same topologies. So, but they have different configuration, space configuration. This is where space syntax can help us to defining and extracting the pattern that behind exists behind this layout, and how we can extract this information and how can we build this is the question and the problem we're going to tackle and talking about in this phase. And the different and also we can talk about that we're going to talk about that how defining the topology can lead us to the geometrical shape, and how the reversely we can extract information from the plans that is drawn. So the space syntax that describe it needs is required graph to start this analysis. So the requirement which we need to have is a graph. So we need to talk about a little about the graph theory and its implementation in design. So how and the so because the graph could have many the definition in different contexts. In the architectural plan that we talk about, each node or vertex or vertices represent a specific space for us, and the edge that connect these two spaces or nodes represent the relationship between these two spaces. The metric that we use for this relation is very it's the important part. For example, I'm talking about the school plan. For example, I'm going to talk about the school plan. So the node I representing, for example, in this node, the nodes 4 and node 8 are two a school room, and they and consider the space or node 7 as a utility space. So the relation between them could be as a personal exchanging, or the supporting the space that support the other space, or two spaces that are are sharing their persons, or the habits are moving between these two spaces. The metric value that we use for generating the relation is very important, and we are going to talk about how this can change the result of our final output, and talking about the circle that can be described about it. So this is a graph theory, and when we describe the graph and represent nodes as spaces, the bold linkage or the bold edge shows that can represent the cost that we have to pay in the terminological way to reaching from space I to space j. For example, if I want to go from space 3 to 13, I can just passing two way and passing two spaces and reach this space. Uh, and so if we want to exactly calculating the hierarchy of the steps and calculating each step values and cost, if when the space numbers are getting much more bigger, it becomes a complex task. So the justified graph that space syntax provided for us make it easy to understand the space hierarchies. So in this organized graph, you can easily understand that if we want to go from space 0 to the space 5, you should pass 1, 2, 3, or 5 steps. It shows that space 5 is in the depth 5, so, and it's the most deep space in the graph. When we start our movement from the space 0, and I think I said the basic information. And this is an example of how we can representing the space relationship as a numerical value. For example, in this plan, we have eight spaces, and we name them in this column and representing the relationship here. The relationship that we consider in this plan is the adjacency as the as two spaces have same door, for example, and you can go to the spaces within a door. If the two spaces have same related door and are in the and neighbor to each other, we consider the relation between these two spaces, and representing here, for example, main entrance, which is here in space. I think it's a little confusing. I think it's not true.
Space 0 is the main entrance. Yes.
Yeah. if you want to change it here,
No,
you can
please
see
don't
that.
change.
Many trends. Many trends is related to. Let me just delete it to see the name of these spaces. Excuse me. The main interest is here. So we have the lounge and garage in the neighbors, but the garage is not directly related to the space, so we didn't represent a relationship for it. The spaces which are related directly to this interior are stairsway and lounge or the bathroom in here. So I will show this in the example of the grasshopper definition. I will send the file to you and we are going to calculate it together. The output of this relationship schedule, which is provided here, representing as a graph in this way, and then we can calculating the steps of each space uh, for moving from steps for moving from spaces to other spaces, and representing these cost values as a bar chart here, as a graph chart here. And before starting our work, I will send some example files to you. Everyone have thermodynamics installed in their rhinoceros. Yeah, let me just. If anyone didn't have thermodynamics installed in their computer, please install it to start our work. I don't have any other person's picture here. Yeah, thanks, Danny. Here, let me just open it. So let me just sharing the file to you. How can I share it? This where is the chat button?
In the bottom line, you have chat.
So how much time we have? How is it possible to have a break and continue, or just continuing to what's the audience and participant idea?
I don't mind. We can keep going, I guess. I think everyone has it installed, maybe. I'm not too sure.
I do have it installed as well, so whenever you want to start.
Wait for participant who didn't install yet to install the program Thermidness, and I will send the example file to you to open it, and we are going to start. So you have the chat here. Let me upload it to you. So if you download the file, please open it and open the folder graph and space syntax.
And it would be better if all other participants also turn their video on. We can see they have interactions with us. It's now a little challenging.
So everyone have the example file?
I'm sorry, which one are we going to open?
Open the graph and space syntax folder, plan 01.
Okay, thank you.
Yeah. So I'm continuing to. I don't have other participants' attention if they have the file or no. So we'll start. By the way,
they can also, excuse me, they can also write in the chat ribbon if they don't want to participate via video. They can write if they have any.
If you have any question or no, or you have the which file do we open? So if you can hear me, open the space syntax and graph folder plan 01. I will share my screen and show you how we are going to work with these files. Any other question? Any other participant? Okay, you're welcome. Okay. So, let me just firstly introducing these components in here, and then we are going to talk about how they work and what kind of data we have here. Uh, the components you see here are from the thermite-maze graph networks category. The first component is a graph maker, which read the imported data and trying to creating a graph based on the relation you provided and the space names. And the result of the provided graph is and then you can select the index. You can select the index which you want to start analysis from it, and then the graph start the analysis and send the output as a tree, which we are going to work with it much more. But at the time we are just using this provided information and to creating the space syntax organized graph. So the process of work is that you importing the data. So as you can see here, when I attaching the panel to the README outcome, it will write that the relationship I provided in the CSV file. If you open the CSV file, you can see that I named the spaces here from the row index 2, but the grasshopper understand them from index 0 here. This is the difference between the CSV file importing and the grasshopper file reading. So don't be confused about it. It might be confusing in the first look, but it's okay. When you want to mentioning a space in the CSV file, for example, I want to mentioning the main entrance relation to dining room. I put the name. Writing index 2 for relationship, but in the grasshopper, it's understand it as index 0 because it's the first row in the space list. Is it clear? Is it okay? If anyone have question, please ask.
So far, so good.
Okay, so as you can see here, you creating the relation and what?
Yes, sorry, can you hear me?
Yeah, I can hear you.
Yes, when I open the CSV file, everything seems to be in the same column. Everything is in the same in only one column.
You have just one column. You don't have a CSV file like this.
No.
Oh.
I don't know if it.
Which one? Which one you open?
The plan 01. I don't know if I can send a screenshot or.
Should open the Excel file.
Yeah. Did you open it in any specific way or?
Oh. So how's the information in the Grasshopper? Is it okay or no?
Yes, in the Grasshopper it's fine.
Does Grasshopper understand it?
Yes.
So the Grasshopper understanding the file, but the representing in the Excel is not okay. You mean?
No. Yeah, everything's in one column separated with commas.
Oh! You open it with the notepad, I guess. You don't open it with the Excel file.
No, I opened it with Excel, but
if you open this Excel program, you will see the schedule like this. So just let me. Can you please give me a screenshot from your CSV file?
Yeah, 1 second.
Maybe the version of Excel. That's the problem.
Oh, compatible with 2013. It's okay. Let me open in chat.
I sent you the PNG file, the screenshot. But it's fine. If no one else is having this problem, I can just kind of recreate the Excel, I guess.
Oh my God! Look at here.
Strange.
Yeah, it's weird.
Very strange.
I don't know. Let me just sending a new file to you and try it. Let me just. So, could you just open the special graph folder and sample plan 01 and opening the CSV file inside it and check it out if it's okay? Going to the special graph folder instead of going to graph and space syntax. The folder with the special graph name, and then to going to the sample plan 01, step 2, and open the CSV file in there and see if it's okay or it's also the same.
No, it's the same.
It's the same?
Yeah.
Don't have any idea. It's just about the Excel mistake, I guess.
I will create 3 different Excels and send it to you so you can combine them in one Excel file. Maybe it works.
Thank you.
Yes. You're welcome.
No, I'm just curious about how the Grasshopper work. Grasshopper is okay with it. It can open it correctly. You don't have any error in the Grasshopper?
No, it works fine. I mean, I can see the same thing as you in your
my screen.
Yeah.
So let me just continue the description, and we will send you the correct CSV file. Okay. So as you can see here, it's named in rows that the space main entrance is related with the WC and the stair because we putting this relation for it in the Excel file. We named as a number here, and it represents for us that which spaces we mentioned in our scale, in our columns. So we can check our relation here with this README file and this panel. This is a dialog that help us to checking our relation accuracy. After that, the other outputs are department lists, which is the name of the all departments we inputted in our Excel file. And this is a connection ID, which is not really well. It's an Iron Python list. This is a connection between all the spaces as a tree that this component provided for us, and graph read it to creating the graph based on it, and understanding the relation between the spaces from this connection ID. And also we have the area list, which is in the column 2 here. So you can see the graph is built in this way because I using the boundary for it here. I can change it. I can change this position. It's okay. This is just how it represents graph in the Rhino environment. You can drawing a rectangle for this component and put and connect it to the graph bound, and it's drawing the graph inside it. And you can changing the text heights with this button. Also, this is not really the numbers are shown here. Okay. This component is a linear graph network, and it can be used for different meaning. But in this step, we are trying to understanding the steps of the space relations and space cost by it. For example, I importing the graph and creating it, and I'm trying to understanding the. We have chats here. Let me just please combine these 3 columns in one Excel file. Okay.
It's because I think Mr. Patrick, you had the problem, so I splitted the Excel file into 3 parts, and you can combine it. Okay, sorry.
Okay. So I created the graph, and I choosing the space index I want to start analysis from. I choosing the space index 0, which is a main entry or main entrance here in department 0. And then this component analyzing the routes that from this space to other spaces, and calculating the cost and routes for us, and representing them as a selected tree to show them numerically here. You can see from a space 0 to 0 has it just standing on its own is 0. If you want to go to the space 1, we have to passing from space 0 to 1. If you want to come into space 2, let me just showing the number here. You can see if you want to go to a space 2 from a space 0, we can go immediately with 1 node. If we want to go to the space 6, it represents that we should go to the space 3, 5, and then reaching the space 6. Here we can go, and this is a representation. And in the next step, the space syntax component trying to calculating these provided data to show it in the organized way, which is here. It shows us that the main entrance can reach these 4 spaces directly in the first with one step, and these 2 spaces are reachable from main entrance by 2 steps. And you can see also the linkage spaces between this step and this step 1, which is the kitchen here. So this is a point that we are going to talk a little much more about. If I opening the plan, this is a random plan. I just downloaded from the internet. It's not really important what kind of plan is it. As you can see, the main entrance can connect with the dining room in 2 ways. You can reach the dining room with the kitchen or with the lounge. So it depends on you. And if you mention in the Excel these 2 steps as the linkage, the algorithm which is provided in the space syntax analyze it and finding the best route for space hierarchy based on the space integration. For example, if the integration for this space is much more than the other one, it choose the less integrated space. In this in this step, kitchen is integrated with the utility 2, and so it's considered as an integrated space and representing the linkage between dining also with kitchen. So we can change it by changing the Excel file, and we can see that how this affects the space syntax hierarchical organized graph. Is it clear? Okay. And here is the linear graph network that shows the values here. If I changing the space index from 0 to we have 9 space here, we have 8, we just have 8. If I change it, you can see it's representing the cost of the spaces related to the selected index. For example, here space 7 is 0, and it shows the cost for reaching other spaces for space 7. And it also help us to understanding the most integrated part, which is the most which is the space is high level of steps. So here let me just changing the Excel file and showing that how it changed in the graph in the space syntax file. For example, let me just set it to 0 again. Entrance comes to lounge and to dining room. I want to check it how it works. We set the dining room relation to space 5. The space 5 is kitchen. I want to change it to I want to connect it with kitchen and lounge. In addition, 9 and 5, and going to save it. And reloading the file to see the result. So, as you can see, this time it selected the launch to connecting this to connecting the dining room to main entrance, and it does it by the integration value. It's used large because it has lesser integration value than the kitchen. So if anyone have any question about this part, please asking, or if anything is clear, we can go on doing the other example and showing much more details about the DSP syntax analysis.
Excuse me. Will you please tell me how did you load the Excel file?
Loading Excel file is just you have the sample file. Yes.
Okay. Yes.
Just turn the boolean off, boolean toggle off, and then turn it on again. It will ask you to introducing the Excel directory to it, and it's open it for you. And if you don't select the correct folder, it will turn into the wrong company.
Thank you.
You're welcome. Is it okay now?
I'm trying. My file has. It seems that I have problem with my grasshopper.
What's the problem?
It's not too fast.
Oh.
I can load the end file. I have to wait.
Every other part.
Maybe I have to close and open it again. Continue.
Is it open yet?
Not yet. I know how should I do that, and I see the false button, but I can't open any file.
Turn the boolean off and then turn it through again, and it will ask you the directory.
Okay, I have to close it. I will do it.
Other participants are okay? Everything's fine? Thanks, Danny. You're always fine.
And also, Patrick, your problem is solved? You could use the Excel file?
No, not exactly, no. So I recreated a new Excel file combining the 3 columns. So I created a new CSV file, but it won't load in the Grasshopper for some reason.
You can
no, when I
you can load it.
No,
Yes.
I can reload the CSV files from the original folder. But,
yes.
I can't load.
Yes,
a new file.
Muhammad just explained to Maral. Excuse me, Maral just Muhammad just explained to Maral. You can click the Boolean toggle that is connected to CSV reader, the first component, and it asks you a file path.
That's what I did.
Yes, and just go to the folder that you saved the Excel file, and it can be uploaded in the folder.
Yeah, that's what I did. It doesn't work.
Do you save the Excel file as a CSV file?
Yes.
But it didn't open it for you. What's the error?
It says solution exception index out of range.
So do you have any blank rows or column in your Excel file?
Could you upload your newly saved Excel file, Patrick?
Yeah, of course.
Yeah, maybe have a look at it. Maybe maybe it's a different type of Excel or something like that. Because I think because it's working in the original Excel and it's not working now on your newly saved Excel, I think there's a discrepancy in the, I guess, Excel that you're saving.
Yeah, maybe it's because of that. Please upload your Excel file.
How about Maral? Your problem solved now? I can't hear you. You're muted.
Not yet. I can't open it. I don't know why, but when I press the false button, it doesn't show me any.
Yes, but you should press it again.
Yeah, you should turn it
Press
true
it again.
It turns to false. It turns to true when I press it again.
Okay. Yes, and then
no
it's
other window.
the. Oh.
Can I share my screen?
Yes.
Let me just stop my screen sharing and see what you have in your screen.
Is it shared?
Now you can share your screen, yes.
Is it shared now?
No, not yet. The share screen is in the bottom row, yes.
Is it now on?
It's going to start.
Okay. Now I think you can see. Yeah?
Yes.
Oh, you don't have components.
Yes.
Do you have a Mac? Do you have?
I think maybe she's using Rhino 5.
Sorry?
Are you using a Mac laptop?
No, it's Lenovo.
Okay, so it's not downloaded.
The Rhino version.
I think 5 or 6.
It should be 6.
Yeah, you must be running on 5 because I was trying to run it on 5 and it happened the same to me, so I had to. Oh, well, that's weird.
No, it's not compatible
with
this version of 5.
I'm 6. As I see here, this is 6.
So, could you just closing your Grasshopper and open it again?
Okay.
Reloading closing your Rhino and open it again. I want to check your version exactly.
Okay, I will. Can you see this is Rhino 6?
I think, Mohammed, maybe it would be better to show them how to install plugin.
No, it's the version confliction. You should using the version 6.20 and upper version.
This is only 6, not 6.20. Maybe I have to download the one you said.
Yeah, I think you need to download the newer version. So we have some chats here. Super weird. What is super weird? Let me just checking out. Oh, Carl have the same problem, I guess. This is a mistake with the CSV file.
And as Mohammed is fixing the problem, I should tell something that we have 2 sessions every day, 2 hours in the first part and 3 hours in the second part. And we have 2 hours break between. So about 20 minutes later, we will have the 2 hours break. So then we will come back and continue with the assignments.
Excuse me, I lost my connection. Come back.
Okay. No, I was just telling about the schedule of the 3 days of workshops.
Yeah.
That we have 2 hours in the morning in the first part and 3 hours in the second part.
So how much time we have now?
We have 15 minutes.
15 minutes. So
15 minutes. Yes.
15 minutes. So let's checking the problems in the rest 15 minutes to being ready for the next 2 hours.
Yes.
I lost my connection, so I don't have the chats by the time. I don't have the message and the uploaded file. Please send me again to checking your problems. Okay. One problem.
So I uploaded the CSV file, the new CSV file that I created, combining the 3 files that Farishte sent me. If you could let me know.
Would you please uploading your CSV file?
Yeah, I uploaded it. I called it step 1.
I'm not too sure what it is, Patrick. It looks like your whether it's your Excel or something, it just seems to concatenate all the 3 columns into the one. And I'm really not too sure. It's the saying.
But so, sorry, when you
I don't have your file upload in my chat.
Sorry. I sent it in private. Wait 1 second.
Okay.
Everyone. Step 1. Is this the right? Wait, I just want to double check it. I'm uploading the right file. Yeah.
Yeah, it's here.
Yeah.
So when I open it in Excel, I can see it in 3 different columns.
Oh, weird! Because if I open your one,
yeah,
it's
as
just
Dennis
one.
said, it's not really similar to the CSV format we provided. Then is right. You have just 1 column. We should have 3 columns, 3 separate columns.
Okay, that's really strange because I can see that file as 3 separate columns.
I will edit and send it to you again. Please check the edited file I will upload for you.
you want to maybe share your screen, Patrick, and then show us your Excel, and then show us how you're saving it? Maybe it's like a file type or something, if you don't mind.
Yeah, of course. So wait, where do I share the screen?
It should be like a share screen button. It's like green.
Result this.
Sorry, can you see my screen?
Not yet. I don't think you shared it.
No, I don't think I shared it correctly either.
Yep, cool. Starting now.
Oh, it's going on.
Sorry about that. So here, when I run false, run true, I go to the assignments folder, the graph syntax. Step 1, this is the file that you uploaded, that you sent us.
Okay.
This works fine.
Okay.
When I go to the folder, plan 1, step 1, this is a file that I just uploaded. When I open this in Excel, this is how I see it.
I don't have your Excel view here. I think you're just sharing your Rhino screen.
Sorry about that. Good.
Okay. So this is our uploaded file. True?
Yes.
Yeah.
Yeah.
So the representation which is here is not true. I don't know why it's representing in this way, but the column should be separated in 3 different columns as name, area, and relation. So if you wanna creating a new file, you
yes, you
should.
have it.
Yep, so you have it.
Which is what I did. So this is the new file I created.
So
save it.
creating a file in this
Comment
format.
eliminated.
I saved it as a CSV. Called it step 1.
Yes.
I'm gonna save it as. So step 1 CSV. Save. Yes. Yes. And now here. Step 1. This is the new file I just created.
Yeah.
Yeah. This is the error I get.
So, could you just please open the CSV file?
The new one.
The step 1 that you created now.
That would be this guy. Wait, maybe I should close it.
No, it's okay. Let me just checking out.
Sorry.
So could you just upload this file?
This is exactly the same file that I already uploaded.
No, it's really different. The file that you uploaded is just have 1 column when I open it.
Yeah, I think that's the problem.
I think that's the problem. Yeah.
I think for some reason his Excel is saving out and it's concatenating the 3 columns into one.
Yeah.
And then his Excel is reading the original Excel as a concatenation of that as well, for some weird reason.
Some kind of Excel problem.
The file that you have uploaded in the chat has 2 columns. Now it's 2 columns.
Yes. I mean, I can
rather than
just so you can.
Yeah, could you get out of that and then reopen your step 1?
Yeah, wait. I'll just
maybe it shows the conversion.
Yes. Okay, so I closed it.
Cool.
I'm just gonna delete this. This is the one I just saved.
Yep, and then open that again.
And it looks.
And it's completely normal. That's weird.
It's really weird.
Let me have a quick Google.
Yeah, I mean, yeah, I'll also have a quick Google and look through the options, see if there's any specific CSV stuff that's inverted.
Let me checking.
I just put up a link.
Let me just checking a little thing. How can minimizing this view? Okay.
Do you mind if I just stop sharing my screen for a second so I can access the chat?
Yeah, go for it.
Yes, we can.
The file you sent. Is it already open? No.
And this is our last minutes of the first session. If you have not any errors, maybe you can start your break and we will come back in 2 hours.
We actually have some errors, so whenever you finish with Patrick.
Okay.
Okay, Patrick, I will do this file and come back to you in the next 2 hours.
Yeah, sure, no problem. I'll keep looking and try and find a solution.
Yeah. Okay. Thanks for your attention and goodbye, everybody.
Okay, we will come back after 2 hours. Yes.
Great, thank you.
Thank you.